Roughly 14 billion years ago, the universe began as a dense, hot point and has been expanding outward ever since. Physical intuition suggests that any object that expands must possess a leading edge, a physical boundary where the thing ends and something else begins. Curious, if the universe is all there is, a physical edge creates a logical deadlock. A wall implies an outside, but if there is something outside of everything, then the universe hasn't actually for everything. The speed of light creates our actual horizon. Light takes time to travel. We can only see the regions of space whose light has had enough time to reach us since the beginning of time. Because the space between galaxies has been stretching, the most distant light we can detect now originates from a point 45 billion light-years away, forming a sphere called the observable universe. This measurable volume contains an estimated 200 billion separate galaxies. This means our perceived edge is a limit in time rather than a physical wall in space. We are simply looking back until we reach the beginning of the universe itself, leaving us blind to whatever lies further out. One theoretical solution is a universe containing a finite amount of matter, but lacking any borders. Mass creates gravity by warping the fabric of space-time. If the universe's total mass is high enough, gravity curves space back on itself, forming a hypersphere. A spaceship traveling in a perfectly straight line eventually returns to its origin. Space could also take a more complex shape, like a hyperdonut. Here, the loops are uneven, meaning traveling in different directions takes different amounts of time to complete a circuit. This geometry creates a cosmic hall of mirrors. Light from one galaxy reaches us from multiple directions. Since longer paths take more time, we see the object at different life stages, witnessing a star's birth in one direction and its death elsewhere. These closed geometries allow for a finite universe with no outside. Space is self-contained, solving the paradox of the edge by removing it entirely. The most widely supported cosmological model suggests space doesn't loop at all. Instead, it likely extends infinitely in every direction. This infinite plane can still grow. Expansion doesn't mean the universe is moving into new territory. It means the distance between objects is increasing. An endless universe would contain an endless variety of stars, exotic new planets, and chemical combinations that produce life. However, the number of ways you can arrange matter is limited. Everything in the universe is built from a finite set of particle types. Think of a volume of space the size of our observable universe. It can hold a finite number of particles, and those particles have a finite number of configurations. While that number of permutations is incredibly high, it is not infinite. If you have a finite number of possible arrangements, but an infinite amount of space to fill, those arrangements must eventually repeat. Statistics dictate that if you travel far enough, you will eventually find a region of space identical to ours, containing an exact copy of you. In this model, infinity guarantees that even the most specific sequence of events is not unique, but is instead part of an endless cycle of repetition across the cosmos. To find an identical Earth, you would have to travel a distance roughly 10 to the power of 10 to the power of 29 times the total size of the observable universe. Because space is expanding and light has a maximum speed, we can never reach these distant regions. Whether the universe is a loop or an infinite expanse, we are functionally isolated within our own horizon. This light speed limit defines the boundary of everything we can ever influence or understand. Our observable bubble contains 200 billion galaxies, each holding hundreds of billions of stars. Even at the speed of light, it would take billions of years just to cross our local neighborhood. The volume of space available to us contains more matter and potential energy than our species could exhaust in the lifetime of a star. Whether or not there are clones in the infinite dark, our observable portion of the universe is large enough to sustain every single discovery we could ever hope to make.